Hello, my name is Carly McAvoy, and today I'm talking about equations containing decimals. There's two different methods we're going to look at. The first method is to clear the decimals by multiplying every term in the equation by the appropriate power of 10. Powers of 10 are 10, 100, 1000, 10,000, so forth. The method two is just leave the decimals in the equation and follow the steps to solve any other equation. So we can just leave them in and work them. And in these the equations that we're doing are very basic, and so it might just be easier to leave them in, and maybe that's what I would do probably. But I want to show you both methods because when things get harder, it's nice to have an alternative. Following method number one for the first problem, I can see that I have two decimal places here. So what I want to do is multiply every number in my equation by 100. I'm just going to write a 100 next to it, but I'm actually multiplying. I could be a little more specific by putting parentheses. 3 times 100 is 300k. What happens when you multiply a decimal times 100? It just moves your decimal point two places, so that gives me 175. 6 times 100 is 600k, and then 10 times 100, well, I have 1 0, 2 more zeros, so I have 1,000. Now I'm going to solve that equation by moving the variable terms on one side and the constant terms to the other. Let's say I decide to move the variables to the left. I'm going to get rid of them over here on the right. So I'm going to subtract 600k from both sides. Remember, I'm lining up the like terms. 300 minus 600 is negative 300k. I have more negatives and positives. And of course, you can use your calculator to do that calculation if you need it. We would really love to see you not using your calculators for something where you're just dealing with a 3 and a 6, because you could probably do that in your head. All right, then we're going to get rid of the constant term by subtracting 175 from both sides. So I still have a negative 300k on the left, and 1000 minus 175, I definitely have more positives than negatives, and I have 825. And again, use your calculator if you need to for that. And then I'm going to divide both sides by negative 300. And there I am going to use my calculator. Because I had a decimal problem to start with, I want to give a decimal answer. And so I'm going to divide 825 divided by negative 300. And I get negative 2.75. So K equals negative 2.75. That was method one, where I got rid of the decimals by multiplying by a power of 10. Let's just look at that problem without doing that. So let's say I want to move my k's to the left. I'm going to subtract 6k from both sides. If I have 3 and I take away 6, I've got negative 3k. And then I'm going to get rid of the 1.75 by subtracting 1.75 from both sides. And that's going to leave negative 3k on the left. And on the right, well, I know I just did this, so I kind of know that it's 8.25. But if you have trouble with doing the decimal subtraction, the reason you can leave them in there pretty easily is you can just put onto your calculator 10 minus 1.75 and get that answer 8.25. And now I want to divide both sides by my coefficient, and the two negatives make a positive and the 3's cancel out, and so I just get k. And what am I going to get when I divide 8.25 by negative 3? I get negative 2.75, which is what I got before. So in both cases, doesn't matter which method you prefer. So you might say, this looks like more work. Why would you ever do that? Well, sometimes there are equations that get more complicated where you will want to do it. But when it's just a match, you're going to blow it out without getting your fire extinguisher out. So sometimes you have tools that are good for later that maybe aren't the most effective for right now. Okay, second problem we're going to look at where it has more decimals. That first one just had one decimal in there. This one's got a 4.7b and a 2.1b. And so I want to get rid of those. One decimal place. To get rid of something with one decimal place, I multiply by 10. This one, I have to multiply everything by 10. not just the ones that have a decimal in them, but everything gets multiplied by 10 if you're going to use method number 1. That moves that over 1. We have 47b. 3 times 10 is 30. This moves that over 1. We get 21b. And 9 times 10 is 90. And then I'm going to solve that equation now that I don't have any decimals in it. If I have 47 and I take 20 away, that's going to leave 26b. Remember, those are on the same side of the equation, so I don't do the opposite. I just simplify like I'm simplifying expression. Now I want to move 30 over there with the 90 because I want to get rid of that constant term. Then I do the opposite. That gives me 26b equals 60. And I want to get rid of the 26, which is the coefficient, by dividing by the coefficient. And in this case, I'm going to use decimals. And I'm not going to leave it as a fraction. I'm going to use decimals because I had a decimal to start with. And that gives me this number, 2.3076. And I think a lot of times it will say round to the thousands or round to the hundreds. I should have included those directions. We're going to round to the hundreds. So 2.31, because that 0, the 7 following that would make that round up to 2.31. Let's do that with the same thing over here. We're going to just start off by taking 4.7b and subtracting 2.1b. That's going to give us 2.6b. Oops. Plus 3 is 9. Then we want to get rid of that constant term, so we're going to subtract 3 from both sides. 9 minus 3 is 6, and divide both sides by 2.6. And we should get the same thing we got over there. And if you could put it into your calculator to see that. Remember, it's always nice to pause and try these problems without my guidance. Did I give you another one? I did. One more, just because this has a parentheses, and I want to mention something about that. If you multiply an equation to get rid of the decimal, you don't multiply inside the parentheses, because that number out front, this number is going to distribute and change that already. So we don't want to change it twice. We just want to change it one time. Since there's one decimal, I'm going to multiply both sides of the equation by 10. The rule is to multiply every term by 10. And this is actually one giant term. Until we separate them out, it's one term. So I only multiply it one time. That moves that 1, so I get negative 21. And that moves that 1, so I have 36. If I distribute here, I get negative 21q. Plus 21 is 36. And then I'm going to subtract 21 from both sides, getting rid of the constant term. Couldn't think of that for a second. And then I get 15. And then I divide both sides by 21. And I have to change that to a decimal because I started with a decimal. 15 divided by negative 21 is negative 7.1428571 blah-de-da. I'm going to round that to the nearest hundredth. In this case, because if you look one to the right, that 4 is less than 5, we're going to keep that as 7.71 or 71 hundredths. But there's also a negative in front of that. So negative 71 hundredths is my final answer. If we didn't get rid of the decimals over here, we would distribute negative 2.1q, and negative times a negative is a positive 2.1, and then we would get rid of the constant term. Negative 2.1q is positive because we have more positives than negative, 1.5. And finally, we would get rid of the coefficient, which is negative 2.1. And if you divide 1.5 divided by negative 2.1, you're going to get the same thing that you got when you had the decimal points moved over. So you don't have to worry about, well, if I change that, am I going to have to change the answer in the end? No, because you're changing both sides of the equation, it works out and you can just leave it that way. Okay, I hope you have a fantastic day.